And then, so we have similar support. This kind of support is extensible for plugins. So we have this implemented for the Apache tools like Ant and Maven. And then I started seeing some of the plugins take advantage of that. So hopefully, this will come to the build tool of your choice down the road. And I guess another thing that once you start using a big cluster, is that how you configure what jobs to run where. So often, even though your cluster as a whole might have different environment, your specific test or specific build often need to run on particular environment. So let's say if a particular test is meant to be run on Windows, then you have to run it on Windows, right? So the naive way of doing it is by specifying that this job has to be run on this particular slave. But if you do that, it sort of hurts the utilization because it could very easily happen that two jobs just so happens to point to the same node for the build environment. And then in that case, they sort of collide. They compete on the available resource while there's another Windows machine, like the Windows #1, idle. So this sort of hurts resource utilization. So to fix this problem, Hudson had this notion of labels. Labels is like the group of slaves. So in a cluster like this, you might have a Windows label, which has those two Windows slaves. You might have another label called Solaris that contains the Solaris nodes. And then the job, instead of specifying that this job needs to run on that slave, you would say this job needs to run on a Windows label. So this gives additional scheduling flexibility to Hudson so that it can choose available machines and do the right thing to build. And also, when you bring in additional slave, and then if it belongs to a particular slave, the Hudson can start taking advantages of it right away without the people making any configuration, without people making configuration changes to the job. Or if you have a lot more slaves, you could actually run concurrent builds. So you can have you can have multiple builds of the same project at different places going on at the same time. So you obviously need more machine resources to do that. But if you do that, then there will be smaller number of changes going into each build. So when you actually have some regression, it's much easier to identify the cause of regression to a particular change set, because each build, let's say, only have 1 or 2 changes as opposed to 10 or 15 changes. And also, if you have some the tests that are randomly fail for no particular reasons, we all have one of those tests from time to time, and then just by running it a lot of times, you get to identify those problematic tests right away. So it's much easier to discover those and act on those. Another thing where we do the work is actually the forecasting failures. So I briefly mentioned earlier, but again, if your cluster size grows, you tend to develop some nodes that have some kind of problem. So, and then the worst thing you want to have, the thing that you want to avoid here rather, is because of those environmental issues like lower disk space or the network connectivity issues or something like that. If those are the factors that make the builds fail, then the people who are using Hudson deployment will start to lose the trust to the cluster. So when they see failures, instead of them thinking that, well, they might have made some changes that cause regression, they start to think that, oh, this must be the environment issue. So let's just wait for another build to come in before we even look at the problem. So that kind of defeats the purpose of CI. So in Hudson, the Hudson makes a proactive monitoring of the environment. So it can look for the available disk spaces or the network response time or the available swap space or any number of things. And if those things go below a certain critical threshold, it disconnects that particular slave. And until the administrator looks into it and bring it back online, it will not use those slaves for carrying out the builds. So in this way, even though your cluster might have some problematic nodes, your cluster as a whole will be healthy. So, so that allows you to, that helps you keep the pristine, the good working condition all the time. The other thing is that the people often don't write good build script, period. And then, so what often happens, I guess, in Sun is that if the test script or build is forking a background process, and that they often fail to clean that up correctly. This is especially common if the build or test terminate abruptly in the middle because they don't have the time to run this compensating action of cleaning it up. So the Hudson has this the support for cleaning up the mess that the build or test have left behind. So it's actually go look into all the processes that are launched during the build, and then if those are still running after the build, we will go after those and kill them. And so these implementations are available on the major platforms. So even with the purely written build script for test environment, you could still maintain the Hudson cluster. So this is the kind of things that Hudson do behind the scene to help you help you maintain the good working condition cluster without doing any system administration work. So so I think that's basically about the distributed build stuff, and I guess I'm about time, right? So yeah, so if you have any questions, sorry for the incorrect order, but.